Welcome to July 17th LeetCode Challenge. 3 equal parts. You are given an array which consists of only zeros and ones. Divide the array to 3 non-empty parts such that all of these parts represent the same binary value. So return any possible I, j, with I plus 1 being less than j, such that the first part is from index 0 to I, the second part is from index I plus 1 to j minus 1, and the third part is from j to the length of the array minus 1. If not possible, return -1, -1. Note that the entire part is used when considering the binary value it represents. For example, 110 represents 6, not 3, while also the leading zeros are allowed, such that 001 and 11 represent the same value. So let's go for some examples here to see how we can develop a solution. So you're given an input, the array as such, and you want to return an ij value, right? Return an ij value that cuts these. So these are the two cuts you want to make in order to make 3 equal parts. So this is I, 0 is I is assigned to 0, and j is assigned to 3. So it's telling you to cut after index 0, which is right here, and it's telling you to cut before index 3, which is right here. So at the end of the day, we have 1, 0, 1, 0, 1, which all represent the binary value 1. Remember that leading zeros are allowed. So 3 equal parts where the binaries are equal. So that's the first example broken down. Let's go for the second example here. So same deal, except however, note that the number of ones here, the sum of all the ones in the array, is not divisible by 3. So if you do a little bit of thinking on that, if you cannot divide the number of ones in the array as divisible by 3, then you're not able to divide the array into 3 equal parts because there's no distribution where you would have a whole number of ones. So that's why you return -1, -1, because there's 1, 0, 1, 2, 3, 4. 4 is not divisible by 3, so you can't divide up 4 into 3 equal parts. That's pretty much the second example. And the third example is giving you here is it's kind of like another iteration. It's so it's telling you to cut after index 0, which is right here, and it's telling you to cut before index 2, which is right here. So this is a kind of a special case where you have 1, 1, and then 0, 0, 1. So note the leading zeros are allowed, so all 3 numbers are equivalent to to decimal 1 value. 1, 1, and this is 1 as well. So let's go over the examples. So let's develop some edge cases here. So the first thing we want to note is whether the number of ones in the array is divisible by 3. If yes, then you're able to continue. If no, it's not divisible by 3, then you have to return -1, -1. Let's define that. So you want to count the number of ones in the array. So let's call it ones. It's going to be the sum of all the ones, of the array, basically. So the sum of the array. Oops, it's actually a array. So note that the array consists of 0 or 1s, and if you do the sum of the array, you're summing up all the 1s in the arrays, and we call that 1s. So you need to know the sum of all the 1s in the arrays. So if you know that, you want to know if 1s is divisible by 3, so take the modulus of that, is equal to 0. It's not equal to 0, I should say. It's not divisible by 3. Then what you want to do is return -1, -1. Right? Because the number of ones in the sum of the array is not divisible by 3. Another option you want to consider is what if you have this right here? You have this array. This array. All zeros. So basically you want to make a cut at after index 0. You want to make a cut here and a cut here. Because the modulus of 0, 0, 0 of zeros would be 0 as well. So if 1s is equal to 0, then return the cut at index 0 and 2. as this is just a special case right here. So now we have two cases out of the way. Next thing we want to do is find the start of. So note how leading zeros are allowed. So the important number to consider is the first one in each followed by a zero. So that means that we're going to copy this pattern after the one, the first one, such that it represents some number, the pattern in a later row, in a later stage of the array. So that's something we're looking for. So we want to make sure that the I guess another way of putting it would be so the number of counts is let's see. If the leading ones don't contribute to any of the binary number, for instance, if you have 0, 0, 1 or 0, 1, 1, 0 or 0, 1, 0, 1. Oh, all the red numbers right here don't count towards, all the red zeros here don't count towards the binary number. It's any number going after the first leading one. And from this kind of from this idea, we know that no number the number starts with from the first one. So that's what we're looking for. All right. So here's what we're gonna do. We are going to find the start index of each of the groups of ones that is important. So we're gonna develop a C count. We're going to develop a start. So we're going to store all our values inside our start list array, I should say. Now we're going to enumerate the array. So for index in the enumerate array, what we're going to do is if the data is equal to 1, so the value is equal to 1, the first index we're looking for, and if the count where we're at, and it's take the modulus of the ones as well, ones divided by 3 is equal to 0, then we want to append just starts with a 1 basically. So this is going to be an array that carries our starts dot pen I, and then the count is going to increment 1. So this is basically telling you to keep track of the index where you find a leading one, where you find the one starts. So that's pretty much it for this one. You're storing all the index in starts, where the index in the starts is the value of the first leading one that you're looking for, of a 1. Alright, now we're gonna do a linear scan to group and compare all the digits together. So for so we're gonna find the 3 parts here. We're gonna find basically I and j such that I and I plus 1, j minus 1, j and array length minus 1. We're gonna find those key values. I mean those key parameters. So we're gonna find some let's see, I, j, k. This we need 3 numbers. That'll be kind of nice. Oops, j, k. Assigned to be start, so it's going to be our empty array. So while k is less than the length of the array, so we want to note that the last group, or the most right a group of bunches of numbers, must include all the digits until the very end. So basically this means that, for instance, if the pattern here must contain within the pattern here and the pattern here. So notice how the first one can be kind of different because of the leading 0 is not there, but the last number, the pattern has to be the same. So for example, you have 1, 1, and then 0, 0, 1. So the pattern of the last leading 0, or leading 1, has to be consistent with the first two parts. So that's what we're going to try to figure it out here. So basically we want to find if the array at index I is equal to the array at index j is equal to the array of index k, then what we want to do is we note that all these are starting basically we're finding the pattern, right? So if we're dividing 3 equal parts, we want to be able to find whether the pattern starts at index I, j, k when they're all the same. And then we're going to increment. We're going to do a linear scan basically for all the I, j, k elements. J plus 1 and k plus 1. So else return -1, -1. Why are we doing this? Alright. So we're going to loop through each one case less than the length of the array. I'm going to find for index I, j, k, if they're equal to each other, that means that the pattern is continuing. So that means that I, j, k needs to be incremented to the next value after I, j, k at index I right here. If we can't make the same pattern, then return 0 because you can't. You cannot make 3 equal parts with them. Alright, and then at the end of the day, you want to return something. You should return. What are we returning? We want to return the value at I and j. Keep in mind, however, I is right here and j is right here. So we're actually looking for the first part of third array and the last part of the first array. Their indexes, I should say. So keep in mind, they're not the I and j that we're cycling through here. They're actually it's actually I minus 1, and then we are looking for actually j. Yeah, that's what we're doing. Index I minus 1, and then j. So that's a little bit of a tricky one because we're returning. It says to return I and j here, where I plus 1 is less than j. So that means that j will be, if you do the inequality, be I minus 1, and then you return j because you want this number here, which is the number preceding the cut, and j is the number the cut before the j. So let's run this code and figure this out and see if it works. Okay, seems to be working. Click submit. Well then, accepted. Awesome. So this is using a linear scan technique. It's the time complexity is running at big O of n. Yeah, because you need to iterate through each. You have to enumerate each element right here, which is n times. But also you do the while loop here as well. But these two are running in the same same block, so it would be big O of n be the time complexity, and space complexity is returning. This is a constant. So yeah, it's big O of constant space. Big O of constant space. All right, that is pretty much it. This was a labeled hard question. It is quite hard. If you don't really, the question itself gives you a lot of hints in there and the examples as well, but it's really hard to figure it out and dissect it into smaller bits, but I think we did it. Alright, have a great day, guys.